All right, welcome everyone to Automation Study Group. Today we have James Dumont talk about
Hello.
best practices in Azure. Go ahead, James.
Hello, Claudia. Thank you. So here in this presentation, we will talk about Terraform in Azure and best practices. As a quick introduction about Terraform, for me, from my point of view, which is a very good tools, the first reason is that this tool can help you to manage your infrastructure in any cloud provider or on-premise environment. And the second reason is that he is able to tell you what is the difference between what's in your code and what's really in the cloud provider solution. So he is able to compare your code with the cloud provider environment and tell you if the modification could be done in place or if the modification need to replace the target resource because its properties implies that in the cloud provider. So let's start with the best practices we will present you. So here the point for you is that we will present best practice, 4 best practices, which you will be able to do it yourself just by clicking on the link which is here down in the demo. It's actually on GitHub, so you can just git clone this repository, read each best practice, and do it yourself. So the first best practice is about using remote backend, which is actually a location where you can store your test states. Then it is the second one is about managing the version of the tools you are using. We will speak about the implicit dependency. It's more about coding. And there is also a link where you can find module published by the community. So do not hesitate to use that if you have any doubt on how to use the Terraform resource. And then we will speak about Azure ARM template in Terraform. So let's go on the first demo. So the first point is about best practice 1, which is about using remote backend. Actually, when you use Terraform, it generates for you what we call the test state file. And in this test state, you have all your infrastructure code, and that Terraform use this test state file to compare it with what's already in production. So it's really important that you have your test state in a secure location, because if you lost it, the Terraform won't manage to compare what you want with what's really in production. And another point is that this test state allow teams to work together in the same environment. About the test state, you have several ways to register your test state. In Azure, I did present here two ways. So the first one is to about the storage account key, is about telling to Azure to upload the test state in a storage account using the access key of the storage account. The second example is about using the same target location, but using another authentication method, which is through a service principal. Okay, so let's do the best practice 1. Here, my objective is to show you that what could be a consequence of not using a remote backend. So let's begin. In best practice 1, we will do a simple code which will it will create a virtual network and assign a role definition to this virtual network. So all my prerequisites are already in place. So I will just initiate the command. So here are the code about the test state. I will launch a Terraform init. This first command will check that the remote backend location, the storage account actually is available, and it will also download the correct version of the resource, Terraform resource you will use. So if you go on Azure, my target storage account is this one. Okay, so I have created I have created a container which is named test state. Okay, so here I don't have any blob. So I will go on my code on the best practice one, which is here on the main. Okay, so I will create a virtual network with a subnet, and then assign the role assignment reader
James,
to
can you
my
make it a little
CRI
bit
principal.
bigger? The font a little bit bigger for people to see.
You mean if I can do a zoom?
Yes, zoom a little bit.
Actually, I don't know if I can do that because on this maybe. Okay, I will check that. Oh. Oh.
Control plus.
Yes, but I'm on a Mac, so no selection. I'm sorry, but I don't know how to do that. Yeah. Actually, is this?
This is good. Yes, it's just on a black background.
This is good.
Yes, this is good. We can see it.
This is good. Okay, so if you'd like to see the code that I just showed, it's also here in the main file. Is it better?
Yeah, this is much better, yes, than on a black
great.
background.
So here we call the resource virtual network. Okay, so it will create this virtual network in this location, and then with a subnet, and then with this resource, it will assign the reader role to my service principal on this virtual network. And the test state will be located here. Okay, it will be named here with the container name test state. So I will launch the Terraform init command. So at this time, we won't write any test state. We will just test that we can access to the remote backend location. So I don't have any test state at this location, but because I don't have any error, the access is fine. I will then launch the Terraform apply command directly. So the Terraform apply will compare an empty test state, so nothings, with what's in Azure. So at the moment, as you can see, maybe it's a bit smaller, but here the Terraform tell me that he will create two resources, the virtual network with the subnet and the role assignment. And if you go on Azure, at this time, the test state just happened. So it's here, and we can have a look on the test state. So nothing is inside because we didn't launch the Terraform apply. We just upload the test state. So the test state is in a remote location. If I go on the resource group, I don't have any resource yet. I will just tell Terraform that yes, I want to create those resources. So it will just do that now. So the virtual network is being created. And, yeah, good. An important thing when working with test state and teams is by default the dev state is in the least state when you launch the Terraform. It guarantees you that no two person in the same time cannot modify the same infrastructure. So now the dev state contain what you just have created. So if I go on it, I can see that there is a subnet IDs that just appeared, and all the component that I want to create. And if I go back to the resource group, I can see that my virtual network is here. Okay, so it just appeared. As we told, I just add a role assignment. So I will just check that it has been done correctly. Okay, very good. So here you can see that my service principal, which is named LV Azure SP, is reader on this resource, exactly on this resource. So my Terraform code just works using a remote dev state. So what we should do now? So now I will just destroy. I will just tell my Terraform not to use a remote backend. Okay. So I will just comment, which is what's here, just to say my code that I don't want to use a Terraform backend. And I will do exactly the same command, so a Terraform init, okay? So at this time, you will just try to write down a Terraform dev state locally on my computer. So the code is not aware that the resource already exists in Azure. Okay. My connection actually is not really good, but we'll manage. Okay. And we will then launch Terraform apply. Okay, great. So I will just launch the Terraform apply. And as we saw in the last Terraform apply, there was no error. He tried to create a virtual network and he did a role assignment. And you will see that actually, as you told me, Claudia, it's a bit small, but in my window, I can see that the Terraform asks for 2 modifications. Actually, we should not be asked for 2 modifications. We should be asked for 0 modification because the infrastructure is already deployed. So this is the case because we do not have any dev state. So Terraform will just ask to recreate the resource for you. And if I select yes, you will see that I will have an error because the role assignment is already assigned. So actually, it's not an error from Terraform. It's just an error from the provider itself, the cloud provider itself. If you try to do it manually, if you just for example, in PowerShell, you just do a role assignment one time, and you redo it again, it will prompt you the exact same error that you have here. It just tell you that you cannot assign 2 times the same role. So this is a point about having a dev state. If you do not have a remote dev state used by all your team, you won't be able to make evolve your infrastructure because you do not have its background. Okay. So this was an example about this, about best practice 1. So always use a remote backend. I have also added a link here at the down that shows you each solution that you have to store the remote backend. Actually, on Azure, the simple way is to have a storage account, but you can also upload your remote backend if you want on a new solution that was provided by HashiCorp Terraform, which is called Terraform Cloud. They provide you for free a remote backend location, so it's a way to store this. So let's go on best practice 2. So best practice 2 is just about managing your Terraform version. Here I point out three type of tools that of tool that the version you have to manage. The first one is Terraform itself. It's really a recommendation to manage this version on your code, because it's just the best practice, because you can break down some new, you can have some new feature that can break your code. So it's very important to do testing about each version that went out. Actually, my point here is not to say that you must fix the version in your code. My point is just to say that define your version strategy. Some guys will tell you that they want to fix the specific version in their code, and other teams that can decide to always have the new version. Both solutions are good actually, but it implies effort on the team. If you want to be always up to date, you have to test your code. It's very important. So here the solution for the Terraform provider is to write down the required version here in this backend. About the Terraform Azure provider, is you can just write it down here. And also when you use remote modules, you can also use tags. So it's really a best practice. If we want to do just a quick test of that, I will just my point here is just to show you that there is a warning. There is a warning that we can see in best practice 2. So if I open my code, okay, great. Yes, here I have just typed required version to this version. If I just comment it, okay, and I just launch the Terraform init command, there is a warning that actually nobody reads, but it's very important. They just tell you that as an advice, you should manage this version yourself and decide which strategy you want to apply. So it's downloading the last version. Up. Oh, come on.
So James, just to clarify, this is not really the version of your code which you're writing, it's a version of the Terraform which you're going to be using to deploy it. Thank you.
It is the version of Terraform, and it is the version of the provider, Azure, and also the version of a module. Actually, for those three kind of resources, there are version, and with this method, you can just say to your code to use this version, because you know that it works in your context, and you don't want to to be impacted by a new version.
Right. So James, if you don't mind me asking again, so the line 31st, where you specify the module version,
yes.
This is your specific module which you wrote, right?
Yes.
And that's going to be the version for your module, right? You can customize it. You can even give it like 7.7.7, right? Doesn't matter. Right?
Exactly. For a module, you do what you want. Actually, with a module, this version is a Git tag that you have set on your code. If I go on my module, so here it's a module that I have pushed on the HashiCorp Terraform module repository. Yes. Oh. Okay. Sorry for that. On the Terraform registry, anybody can push modules. And the module that I show you, it's my module. So here you can see Azure module, AWS, etc., GCP, Oracle, VMware also. And here on my profile, I have published 3 modules. So on my code, I was showing the Azure, the AZ virtual network modules, which is here. And this module at the top has a version. You see 1.0.1.0, and those versions are just the tag, the Git tag version that I have pushed on GitHub. So here, if I go on my branch, you will just see the tags. I have just tag 01, etc.
Oh, this is great, James. Thank you for explaining that.
Yes. No problem.
James,
no problem.
and out of curiosity, just a follow-up question, what would be the benefit to use the modules on your own GitHub repo or in Terraform? Is there any preferences, or it just to share with the community?
In the past, I used to call a module from my GitHub repository, but the version that you can see when I call the module, these parameters is only available when you call a module that's in the HashiCorp repository.
Oh, so that is more advanced than. Gotcha.
Yes, actually, it's more simple, but that doesn't mean that you cannot call a module with a specific tag, because in the source line, you can just write down the URL of your repository, and you can append with the tag version. So this is another way to do that.
Got it. Thank you, James. Again, appreciate this.
And another point with the HashiCorp registry is that you can have an HashiCorp registry public, so which is free actually, and you can also have an HashiCorp registry private for your company, which will be more secure, and the module will only be available within your company. And another thing I like about this registry is that it does the documentation almost for you. Actually, you have to write down a markdown file. So this is my markdown file, and I also add a repository. In my repository, I create a folder which is called examples, and if you go down, you have an example of how to call the module. So it is quite easy to upload, and the documentation is done for you. So it's quite good. And in the input section, you have all the input variables that you have to add. Actually, it just write your code, but the publication way is pretty cool. If I go now about best practice 3, actually I won't be able to do the demo in live. By the way, you can do it yourself. It's ready to be used here on this link. Here the point about implicit dependency and explicit dependency. It's very important to use implicit dependency because it tells your Terraform when you call, for example, two resources. If I call the resource network interface and on the subnet, okay, when I call my Terraform code, by default, it will do everything in the same time. So if you don't do an implicit dependency, you will try to create the subnet and the network interface at the same time, and you will definitely have an issue at the first time. So this is a point about using implicit dependency. It's about the creation of your resource. It tells Terraform to create the resource in the correct order. And the other point, because Terraform is available to create, to modify, and to destroy your resource, if you use implicit dependency, when you will launch a Terraform destroy command, the Terraform will know that he needs to destroy the network interface before destroying the subnet. And this is really important when you do continuous integration and continuous delivery, where you want to rebuild the environment from scratch. With Terraform, you will be able to create all your resources, destroy them, and do it in the environment of your choice. And it will work with no error and with the same code. Actually, I say the same code because if you want to do creation and deletion with your own code, you will have to write the commandlet to create and the commandlet to get and the commandlet to destroy, and make your own workflow will be actually we used to do that, but it's time consuming, and with Terraform it does that for you. I will now go through best practice 4. If you have any question, by the way, Claudia or Line, do not hesitate about best practice 3 because I didn't do any demo, so feel free to ask.
No, this is great. You explained it very well. Thank you so much, James.
I actually, James, if you don't mind checking here very quickly, what about the depends on? Because I also seen in your GitHub repo, you have this switch depends on. Could you talk more about that?
Actually, when you could not use implicit dependency, another way is to use explicit dependency and to add the option depends on.
Okay, can you explain me this stuff, James? What about the lifecycle hook? Specifically when you're doing the destroy. Isn't it something like a flag, if I understand it? If you could just tell more about the lifecycle hooks.
Yes, so the lifecycle is I did use that for the app services. When you create app services with Terraform, so you can create it with Terraform, but the point with Terraform is that if you launch a Terraform plan, let's say 2 weeks later, you don't want that your Terraform plan tells you that there is many modifications. Actually, if there are many modifications, you want to know if those modifications need to be re-updated by your code or not. With the app service, when you tell your teams to publish app services, if they do not use Terraform, if they use another tools for publication, they will modify some parameters of your app services. And with Terraform, you can just say with the life cycle to do not have a look on those parameters. So I used the life cycle option for that, to say to my Terraform code that I don't want to know, I don't want to have a look on these parameters. If it has changed, do not take care about. For example, if you add a tag on a network interface, and I don't want to write to delete your tag, I can add in my code in the lifecycle just to say, but I don't want to have a look on this tag, for example. Was it clear?
That's very clear. No, that's
Yeah.
very good. It's basically kind of a virtual comment, right? I mean, if I don't want to explicitly comment it in here in my code, I could just do the life cycle. Gotcha. Thank you, James.
And this is one use case, and there are other use cases about the life cycle. There are commands that tells that when you launch a Terraform destroy, you will create the resource before destroying. But I didn't use those one, but there are other use cases. This was a use case that I used. I can't speak about, but the other use cases could also be benefits depending on your usage. But it's all about the life cycle about the resource, actually.
And James, I only have one more question left, and I don't know if this is the right time to ask. Let me just ask you, and then you'll decide when to answer. Maybe in the future modules as presentations. In Terraform 12, right? Right now we can use the object parameters as an object, and
yes,
from what I was, yeah, it is. However, that's not many examples, and to be honest with you, I'm still lost when I keep reading in the book that you can use the modules, exactly what you showed to us, but then you can output the whole entire object. And then you're going to decide which part of that object you're going to be utilized, exactly like in PowerShell. But how does it work in real life in Terraform? Again, maybe not right now, but in the future, if you could tell us more and probably with an example, that would be, I think, beneficial.
Yes, I can actually. I did it for, but yes, but the screen is too small. But maybe I can. I won't go on a deep dive, but just to have to get you an overview of that. I am actually preparing a module about app services. So the point of my module is to create any app service you want with an app service environment, an app service plan, or etc. And when you because the module is creating any number of app service, I can just output here on my module a value of everything I want to output of my of the resource that I created. So here it will be a list of map in Terraform. So that was not possible in the past, and now it's possible, and it could be very useful because here you can see that you can for example, you can take the outbound IP addresses of the app service, and you can read this information and integrate it in your module that create a MySQL path services to create the firewall rules, just to say that your MySQL service can be accessed only by the the public IPs of my app service. This is an example of usage of these output values within an object. So this is an object, a list of map.
Got it. Yeah. So James, whenever it's going to be, this module is going to be ready, as you just said that you're still working on it, I think we would love to see it in the real action, like with the demo, because that would be really awesome.
This module actually is pretty good. But we'll see that later. No problem. Okay, I will just go through best practice 4. Also, I won't do the demo because sorry, I'm lacking of time. But here the very important point is, as I told you in the previous demo, Terraform is able to create, to modify, and to destroy. When it does the modification, it calls the API of the cloud provider and he asks if the resource parameters, if one resource parameters can be updated in place or not. This feature with the destroy feature are both features that you cannot have with ARM template at the moment. For this reason, I do not recommend at the time being, to use ARM template. But sometimes you do not have the Terraform resource. It is not ready. So the best practice here is just to use an ARM template if you don't have another way. And here there is a sample on how to create resources through an ARM template through Terraform. And then when you are done, just create a feature request on GitHub. Actually, the community works very fast and is very great. So do not hesitate to create an issue. Just to give you an example, I did create a module, virtual network, which create virtual network, subnet, network security groups, etc., and Azure Bastion host. The resource Azure Bastion host was not available. So in my module, I just had the call to an ARM template. And this feature just went out yesterday with the 1.36 version of the ARM provider. So which is it's great now. I will just update my module to use the definite resource. Why that? Because when I test my module, my objective is just to validate my code. So I launched the Terraform apply to create my resource, and I launched the Terraform destroy to destroy my resource. But when I launch my Terraform destroy command with an ARM template, it does not destroy the resource that have been created by the ARM template. So I could not test my whole process of building and destroy with ARM template. So there is the point. So if you go on best practice 4, you can write down here. So I just launched my command. As you can see, if you do the lab, you will see it. If you go on the deployment panel, you will see that the resources have been created. So here we are creating a load balancer with outbound rule through an ARM template. So you can see the deployment, which happened very good. And when you launch Terraform destroy, it does destroy the deployment resource here. So you won't see anymore in the deployment panel. But if you go on the load balancer, you will see that the load balancer is still here. It has not been destroyed. So in this context, you will have to destroy it yourself. So there I am with the best practice. So that was my last PowerPoint. I hope it was fine, and you did understand things. So do not hesitate if you have a question. Feel free to ask, and I hope you enjoy the session.
Yeah, thank you so much, James. Great presentation.
Thank you.